It's Monday the 10th. We still got some sun. The weather is supposed to get very poor. Of course, we've got the moon. What I'm doing is I am playing with ASI Studio using 150 ED, which I call Eddie. Got the laptop out here. What I've been playing with is doing mechanical adjustments to the azimuth and to the declination, with the idea that, of course, the way I used to do it through the eyepiece on a 6-inch Maxitop was to watch the drift over time, and if the drift headed off in weird directions, just make slight adjustments. So what you're seeing there is the moon, a much better view of the moon that I got last night using ASI Air. This is ASI Studio. Far superior in terms of image quality and control. You'll notice I had the moon set up so that this gap was equal on both sides, but it's drifting to the left, and that usually suggests a bit of a declination error. So I'm going to adjust declination and center it up once again. I'm using the planetary imaging with a gain of 50, or exposure time of 50 milliseconds, and a gain of 0, so we're not adding any additional sensitivity to the CCD imager. There's no way of adjusting the histogram that I can tell. The color green in the moon is due to the fact that I'm using a dark sky filter. So there is our view. Now, what I'm going to do is watch it drift over time. I'll turn the camera back on, but look how clear and sharp it is compared to the ASI Air image I was getting last night, which I've included in this video. So all I've got right now is the moon. Oop, I just bumped my head against the scope, but it recovered nicely. All I've got right now is the moon, although I haven't been able to do any kind of alignment. So what I'm doing is just alignments to the moon, and I'm going to go to Jupiter next after I open up this, and we've had a chance to do the azimuth and the declinations adjustments for a while. Okay, it's now about 8:20. As you can see on the screen, 8:21. This is a view of Messier 42 at 1 second exposure time with a gibbous moon using the ZWO camera and the f8 150mm ED Skywatcher refractor. This is kind of like the view I would expect to get on a decent night of seeing through a 6 to 8 inch telescope. What I'm going to do now is I'm going to step through some exposures, and then what I want to do is actually want to see what we can do with galaxies tonight. So we'll move on from this. It's a good start on the evening. Here we have a nice 5-second exposure. And that would mean we picked up, let's say, another magnitude and a half plus. So we've doubled our aperture probably to about a 12-inch view. As you can see, Messier 42 has got color in it. You've got a brighter middle section. You can see the eagle spreading its wings, and you can see the conch shell M43 right off over there. One more exposure at 10 seconds, and let's go after some galaxies. Okay, here we've added about half a magnitude, maybe 0.8 magnitudes in depth. We've basically taken 12 inches, divided by 2, you get 6, add it to 12, 18-inch scope. So this is kind of like an 18-inch scope view. Now remember, we are having a gibbous moon right at this point. It's probably some 50, 60 degrees from the Sword of Orion. Some things to point out is this nebulosity down here that revealed itself with some dark regions here. That's a very nice view. I'm quite impressed with it. I'm hoping it turns out as well on the Sony Handycam as it does on the screen before me. What you're seeing now is NGC 2022, Planetary Nebula in Orion. No, not a galaxy, but I did come across it while I was searching for the 2000 series. It's magnitude 11.7, smallish, 28 by 27 arc seconds. Has a magnitude 15.8 central star at distance 8,200 light years. We're right ascension 5 hours 42 minutes 6 seconds with a declination of plus 9 degrees 5 minutes and 12 seconds. Now the key here is, let's let's do our magnification thing and see if we can turn out that central star. I'm a little disappointed in the focus right now. Temperatures may have actually changed the focus on us, but that's a pretty 100% view, so we're operating probably somewhere around 350x of this planetary nebula. We're not seeing the central star. I would be surprised if we did on an evening such as this. I'm not happy with the focus. The scope is actually equatorially flipped. Let's stay with that. Typically, it's a very difficult planetary nebula just because of its small size. Well, here we go. We're seeing the faint glimmerings of the Flame Nebula, NGC 2024. Once again, not a galaxy, but part of one. Let me give you some data on NGC 2024 before we move on to see what else might pop up. 2024, also known as the Flame. What I'm going to do here is, because the moon's out, we're not getting the best view. I'm going to go to a 30-second view and give you some of the data on it. Now remember, this mount is very stable compared to the, geez, I can't even remember the name of it right now. Anyway, because I'm so totally overwhelmed by Losmandy G11. Anyway, so here we go. EQ6R Pro is the mount with El Quattro on it. Let's see what we get. We're still exposing. Transfer rate should be very high, yes. That's a much fuller view. That's a view that's comparable to something you might get through the Rev 2 at 128 to 256 flood, but this has got a moon, so it would be far more apparent. Let's skip along again after leaving the Flame Nebula. All right, what we should be seeing here is NGC 2073, a galaxy in Lepus. Magnitude 12.4, 1.5 by 1.4 arc-minute, lenticular type, 134 million light years distant, right ascension 5 hours, 45 minutes, 53 seconds, with a fairly negative declination of 21 degrees, 59 seconds. Now, one thing I have learned about galaxies in the past using this system is they really don't start to come out until you run up the magnification. Unfortunately, we are not getting a very clear view of anything this evening. I am going to have to reset the focus because we are not going to make out that galaxy amongst all those faded stars. Okay, what you're seeing here is Messier 78, and I'm going to play with the histogram a little bit. I got it way too dark. See what we can do by expanding this up. Yeah, that's better. Not a particularly good view. The nebulosity is faded out due to the moon. I'm not going to go ahead and push it to 30 seconds. That'll be our view of Messier 78, which is also NGC 2068. No data to be got on that. I want to keep moving forward for galaxies. You might note over here that since I expanded the screen all the way out to fill the laptop display, now I'm seeing the histogram. I also put it on continuous modality instead of a single shot. And the reason for that is it begins to stack images. Let's see if we zoom in on this, if we can see this galaxy. It does look like something faint right about there. Keep an eye on that. Yeah, the stars look better, but they still look a little distended. This is probably our galaxy right here, NGC, the one we visited before, 2073. I'll get the data on it once again. It's pretty far south. We also got a moon, so I wouldn't expect much in the way of a view. NGC 2073, galaxy in Lepus, magnitude 12.4, 1.5 by 1.4 arc minutes, lenticular spiral, 134 million light years distant. We're at right ascension 5 hours, 45 minutes, 53 seconds with a declination of minus 21 degrees, 59 minutes and 59 seconds. That looks pretty close to minus 22 to me. All right, the screen you're seeing there is the remnant from the last galaxy. This is a new one, NGC 2076. It's about 10 degrees further north than the last one. I'm going to go ahead and leave it on whatever the zoom effect is right now. This is a magnitude 13, larger, 2.2 by 1.3 arc-minute sized, oblately presented spiral with a lowercase a, 99 million light years distant. Right ascension 5 hours 46 minutes 47 seconds with a declination of minus 16, 46, 56. It's quite obviously right over here on the screen, no central core that goes off and fades off into space, but rather largish. Now let's go ahead and do our experiment with zooming and see if it gets any brighter. It really doesn't seem to. Okay, so if we go back to what I consider as an optimal view of about 60%, we'll move on to our next study for the evening. I'm pretty sure you can pick this galaxy out. It's NGC 2110. It's on the screen. I'll give you the data. Why don't you estimate what you think it might be? Pretty intense core, fading out, but not star-like. But it is very present on the screen. And there's a little bit of wispiness going off to the 3 o'clock point. This is NGC 2110. It's a galaxy in Orion, magnitude 14, so not bad, 1.7 by 1.2 arc-minute size, apparent size lenticular, 101 million light years distant. We're at 5 hours 52 minutes 11 seconds with a declination of only minus 7 degrees 27 minutes and 24 seconds. Getting closer to the moon, but getting clearer atmospherics. Let's go ahead and see what our current setting is. That takes us up to, let's go to 100%. Yeah, that really brought it out, didn't it? But let's drop it back to about 50. There we go. Trying to put in NGC 2119 in the handset. Faintish galaxy, I do believe it's right there on the screen. It's magnitude 14.6, 1.2 by 1 arc minute, elliptical, 158 million light years distant. We're at right ascension 5 hours 57 minutes 26 seconds, declination of plus 11 degrees 56 minutes and 55 seconds, but we're getting much closer to the moon now. Let's see if zooming will bring out more of this galaxy. And there you can see it, but we're kind of losing it amongst all the stars that are also a little oblate and diffuse. So we'll go back to our 50% setting, which gives us the best aesthetic view and does reveal galaxies of magnitude 14.6. But I want to point out that could be the blue-violet. And since this is an elliptical galaxy, it could actually be something more along the lines of a 13th magnitude visual galaxy, and I won't know until I do some research. We've gone deep south once again. This is an NGC 2139 galaxy in Lepus. The Hare, magnitude 11.6. Largest, 2.9 by 2 arc-minute spiral with a bar and lowercase c, so 3 times removed from lenticular. 82 million light years distant with the right ascension. Now we've crossed over to the hour 6, 1 minute and 8 seconds, declination of minus 23 degrees, 40 minutes and 22 seconds. And it's pretty clear to me our galaxy is right there. And after a while your eye gets to the point where you can kind of pick them out when you do imaging. Kind of smallish, but it is fairly far south. We could do a zoom, but I want to move on to something, maybe we can come up with something more spectacular. One thing I would like you to note is I haven't really been playing with the histogram much, which gives a much darker screen, but more aesthetic, but we do want to make those galaxies a little clearer, and that's probably about a bad setting right there. I'm going to slide this up, that darkens everything, bring this down. That brought it out a little bit, so I think the original setting there was pretty darn good. Much better aesthetics. Once again, folks, sorry if I'm doing a lot of experimentation, but that's the phase I am in with this ZWO system and its associated software. In this case, ASI Studio. All right, the screen is brightened considerably because we've gone deeper south again. This is NGC 2211, a galaxy in Canis Majoris, the big dog. Magnitude 12.7, 2-to-1 aspect ratio, 1.4 by 0.7 arc-minute spiral with a bar of the lenticular class, 90 million light-years distant. Right ascension 6 hours, 18 minutes, 30 seconds with a declination of minus 18 degrees, 32 minutes, and 15 seconds. The galaxy is quite present, as you can see, magnitude 12.7 on the screen. Okay, what we're hoping to see here is NGC 2223 galaxy in Canis Majoris. Brightish, magnitude 11.6, 3 by 2.6 arc-minute spiral with a bar, lowercase ab, 123 million light-years distant. Right ascension 6 hours, 24 minutes, and 35 seconds with a declination of minus 22, 50, 19. I would say the galaxy is probably right next to this brightest star right there. Not a particularly good look. I am going to shut the camera down and see if I can't find something that would give us a final Carpe Noctem view of the evening of interest. All right, NGC 2274 is a galaxy in it's a galaxy in Gemini. 12.1 magnitude, so should just be visible in an 1/8 inch scope at the eyepiece. 2.4 by 2.4 arc-minute face-on elliptical, 231 million light-years distant. We're right ascension 6 hours, 47 minutes, and 17 seconds with a declination of plus 33, 3401. We're almost overhead, within about 10 degrees of being on the zenith. Let's see what we can do here with our histogram settings. Ooh, that improved it quite a bit. The galaxy is quite visible now. It also seemed to clarify the image a little bit. Let's go up to 100%. You can see a brightish core with some extensions going off, especially towards the 6 o'clock direction. Maybe a little bit too much there. Some extension. Looks like there's a bright line across it, but that's probably just an artifact. We're starting to see some spots on the screen at this point. Once again, we're operating at about 90%, which means, well, maybe 4 times 70, about 280x. That is not a bad view, but it is, in fact, a magnitude 12.1 galaxy with an average surface brightness of probably somewhere around 13.5. But we can't pick it out on the screen, and with that, the only thing I might want to do is go have one more look at Messier 42 as our Carpe Noctem moment. What we have here is a highly over-magnetized, magnified version of, let's fill the screen with it. Filling the screen with it is right around 40%. Yep, 40% probably puts it at 2 times 70x, about 150x. Very nice textures. Unable to resolve, of course, the trapezium. You can see the eagle's beak here, the wings wrapping around. You can see all kinds of texture in both Messier 42 and 43. Looks very nice on the Sony Handycam screen, but I do want to play a little bit with the aesthetics on this one. Ooh, we lost too much there by removing that brightness. Let's see what we get when we go here. All right, darkens the background sky appreciably. That is probably our best view. Messier 42 and 43 bidding you a good night and Carpe